You have chairs.
Yeah.
Chairs.
Folks, I'm back on. I'm now in the bowels of the Natural History Museum with a very select bunch of people who are helping us to put this on, notably Sarah, who is going to show us around some of the meteorites. This is Pete, who's going to film me and us doing this stuff, okay?
Oh, that's me. That wasn't me. Hang on. There you go.
Okay. This is Sarah, Professor Sarah.
Yeah.
Who
Hello.
will tell you all about this stuff. I have
Absolutely.
never been here in my life, even though I've been in the public park.
You should.
It's a real treat. For
Yeah,
me.
so we've got one of the world's best collections of meteorites here. And we study them because nearly all meteorites come from asteroids, although a few come from the Moon and Mars as well, so they're also super cool. But I mostly study asteroidal meteorites like this one. And these formed about 4.5 billion years ago. These rounded objects in them, which are called chondrules. These were once free floating in the dusty disk that was around before the planets were around. So they can tell us about what the environment was like at that time and how these first solids came together to make planets.
Very good, very good. Just make sure you're still saying good. Amazing.
Yeah, so have you
This
seen
has been
many...
cut and polished, right?
Yeah, this one's been cut and polished. So most meteorites are made of stone. Some of them, like this, are made mostly of iron. You know, have a look. And
we think these are from the cores of bodies which split up, right?
yeah,
Metallic cores.
exactly. So like the Earth has a metallic core because in its early days it got hot and all the metal sank to the centre. We think that same thing happened for asteroids as well. Yeah. So you can hold it if you like. This is the oldest thing you'll ever hold in your hand. It's
I'm pretty
older
old
than
myself,
the
Sarah. So tell me, what is this?
Yeah, so this is a piece of a meteorite that fell in India. It's called Ponley. All meteorites are named after the place where they land, so they're all named after a geographical place. And it is what we call a chondrite. So this is one of the really old ones that didn't get a chance to melt, like this one has melted, but this one hasn't. So it still contains all of the stuff that was around the disk before the planets formed.
So what here is closest to what we think we'll find in BENNU?
That's a great
What
question.
would you say?
So I think it's most likely to be something like this. So this meteorite looks is almost black, and it's a kind of meteorite called a carbonaceous chondrite, and we think that BENNU might be something like this because BENNU looks very dark.
Yes, indeed.
And BENNU might contain water and organic material. So possibly the most similar in our collection to BENNU might be the Winchcombe meteorite, which fell a couple of years ago here in the UK.
Right.
So that would be super exciting for us because we've spent the last 2 years looking at Winchcombe.
Is it here? There's a piece of it here.
A piece of it is just over there. Yes. So we've got this fancy new glove box,
Amazing.
which is full of our carbonaceous chondrites, including our bits of Winchcombe.
I'll switch the light on so you can actually see what's going on.
Hi. This is our meteorite curator, Natasha.
Hi,
Natasha.
nice to meet you.
Thank you for helping. Oh, look at this.
Yeah, you can see what's inside. So Winchcombe obviously finds so many pieces. Everything is in individual glass vials, all weighed out. And then they're carefully put in through the antechambers, the vials filled with nitrogen closed up, and then all in their own individual labelled
Amazing.
boxes. Quite a feat of curation.
That's great. The nice thing about Winchcombe is it didn't sit around for too long, right?
Exactly.
They found it quick,
was
so it didn't get very contaminated.
absolutely. It was collected less than 12 hours after its fall. So yeah, the homeowners were completely on it. So they collected it really cleanly right away, which is just an amazing favour to us. Yes. Because contamination is one of the biggest issues with meteorites. That's why we need sample returns, so that we get something that's completely uncontaminated.
That's why we need a space mission.
That's why we
Can
need
you show us how this works?
Natasha can show you as well.
I don't want to touch it.
Yeah, absolutely. Yeah. Okay, so basically, just switch it on. It goes into an eco mode because otherwise it's so noisy, it's crazy. So this is ultra pure nitrogen, which is pumped in along that pump into here. Now it's actually like a self-regenerating system. So it doesn't always pull in nitrogen unless you're using it, but what it does is use the nitrogen that's in there, which passes through HEPA filters and VOC filters, and then also a load of what is basically copper wire, which scrubs out the oxygen. So this is set up to keep the oxygen at less than 0.5 ppm, but it doesn't control amount of water because we don't want to be dehydrating our carbonaceous especially. So that's what the copper does, scrubs out all the oxygen, and then it passes back through another filter, and essentially if you don't do much with it, it can just run on what it is, you know, what it's got quite nicely, which is great. We don't want to be changing the nitrogen all the time. Places like JAXA, yeah I know, whenever the pressure goes too low. And people are always like, it's trying to give you a hug. But, so places like JAXA and JSC, they have constant pure nitrogen coming in because they're making it on site. So whereas we need to use a bunch of filters because we don't, especially with an old building, we never get them to agree to drill a hole to do all this kind of thing. Anyway, so in order to use it, you want to put your hand in?
I'd love to.
Okay. So what the easiest thing is if you get one finger and then the other finger and then the other finger, you know, so you're kind of going from the bottom one, wiggling your way. It's really hard for me because it's obviously, see I've got a step here, right, because it's built for tall people. So the engineers did this for me. Actually, I might move it out of the way because you're tall enough that you won't need it.
Okay.
Can I just put this up against there?
Who would have thought? We would have so much fun.
I love this thing.
This must be normal.
It's really good fun. Okay, so then yeah, do this one. I'll hold it a bit still for you. Okay? And then your thumb.
Yeah.
Okay, now you have to keep aim for the middle of the glove, and I'll kind of hold on to this a little bit.
Okay.
And what you do is you just push your arm all the way through, but do it slowly so you don't increase the pressure really quickly. So you see, you feel it pushing, so it's on an overpressure, yeah. So you push your hand slowly in. You just don't want this to get above 10, so yeah, you're good. And then you can push your hand all the way and stretch it, and then you'll get your fingers through. See what I mean?
Yes, I do.
There you go, there's the knack.
I know.
You get it! But while you're there, can you just rearrange everything? And create other... I can't reach the ones at the top, so...
I'll sort it out.
Thank you. That's it, so same with this one. Oh, I should have got a picture of that.
Brilliant, I love it.
Yeah.
So now I can just take anything I want.
Well, you'd have to get through this vacuum system, so no. Good luck.
Ah.
So actually, if you want to pick up this one here, this is actually Murchison, a large piece of Murchison, yeah, which is a CM chondrite that landed in 1969 in Australia. And it's one of the ones that studied a lot of the time for its likeness to what we think BENNU is going to be like. So it gets used as a practice sample all the time. We've got all the main masses of a lot of our carbonaceous in here because we know we can keep them in a pure environment and they won't be touched, you know, we don't need them. Whereas smaller subsamples we've got in desiccators that we can get to easily, whereas these we know will stay as pristine as possible for as long as possible.
So this probably looks a lot like a piece of BENNU, doesn't it?
Mm-hmm.
It's interesting to remember that these things only reflect about 2 or 3% of the light that falls on them, so it's like a piece of coal, really. And the pictures look nice and bright, but that's because there's some compensating. So how long have you had this?
Since 1970, yeah, very soon after. So actually meteorites in Australia, they can't just be exported, you can't just take them out, but we have very good working relationships with museums around the world, and so yeah, we've got quite a bit here.
Wow.
It was a really good year, 69, because they were practicing a lot of things for the Apollo return. And so plenty of labs were being set up around the world, and then having Murchison and Allende was good. So that one's not set up yet because in order for you to get your hands in, I had to move the stage around because it's quite a small one. But
so this is stereo microscope as well, right? So you look at these things in stereo, interestingly.
yeah. It's mostly just for sample selection because you're quite limited as to your dexterity to curate the samples. Yeah, you're sort of limited as to how much you can do within the glove box. So we use the binoculars to pick the samples that we want. This is what our small sample of BENNU will be kept in as well, where we'll be able to then pick out the sample that people want to study, and then we can take it out of the glove box to mount it.
Where do you photograph it? You look at it through this, but where do you photograph it?
There's a built-in camera,
On this?
which then connects just to a laptop.
Can I see it then? Can I see it here?
I've moved the stage out of the way just so that we can do that, so it takes a little bit of setup to do
But you
imaging.
can focus here, I think.
But yeah.
Can you do interocular separation here? No, probably not. It's really quite hard to set up. That's amazing. So I'm done, aren't I, really? I can't do any more damage.
Well, what you could do is that Murchison piece, if you can put it into that metal tray for me.
Yes.
That's where it goes.
Which one? This one?
The one on the left-hand side, yeah, you might need to pull it out a little bit and then, yeah, there we go.
Okay.
So can you imagine the arm's much shorter than yours?
Yeah. Thank you very much. I'm coming out. Thank you so much.